So today's meeting, I'm gonna focus on few things, nothing new, completely new today. We are done. We talked about indeterminate structure, and I explained what is the meaning of indeterminate structure. Indeterminate structure in few words, number of unknowns greater than number of equations. We have many methods to solve indeterminate structure. One of them, moment distribution method. And I explained what is the advantages and disadvantages of indeterminate structure. So let me ask you a question. If I have a structure, will be suffer. This structure will be under the effect or severe effect of temperature and settlement. Do you like to make it determinate or indeterminate? If we have a structure, I would like to make it cheap. Cheap, no, not expensive. What do you think? What type of structure we recommend? If we have a structure, I would like to make it stronger. Stronger, less deflection. Less deflection. What type of structure do you recommend? If I expect something wrong will happen to the supports, car accident, any reason we can expect losing of one of the support, do you like to make your structure determinate or indeterminate? Do you remember? If your structure is determinate and you lost one of the piers or the support, catastrophic failure will happen. But if your structure is indeterminate, can survive, probably can. So probably I'm gonna ask you few questions, few short questions. What do you like, determinate or indeterminate? So be careful, please study this part carefully. Here you go. If you have severe effect of temperature or settlement, we don't recommend indeterminate structure. Indeterminate structure will cause additional stresses. We recommend your structure to be determinate. Okay? We started to solve how to solve indeterminate structure using moment distribution method. One of them, how to calculate the stiffness factor, how to determine the distribution factor, and one of them is the fixed end moment. Guys, probably I did some confusion about the sign, but it doesn't matter, I believe. If you assume clockwise direction is positive, okay, counterclockwise will be negative. That makes sense. So I agree, clockwise will be positive, counterclockwise will be negative. If you assume something different, that's fine. But one will be positive and the opposite one will be negative. Okay? So it's not a big deal. So let's say, or let's assume the clockwise direction is positive, so the counterclockwise will be negative. Positive, negative. Positive, negative. That makes sense? I need to focus here for something. Guys, can you look to this beam and this concentrated load which is coming down? If the concentrated load is coming down like this, your direction of the fixed end moment here will be clockwise and there will be counterclockwise. That makes sense? What will happen if, so one more time, if we have fixed, and the concentrated load is coming down, your fixed end moment direction here will be clockwise, there will be counterclockwise, whatever the value. What will happen if you have fixed, and your concentrated load coming up? What do you think? I think because the load is opposite, the direction of this moment and this moment will be opposite. In this side will be counterclockwise, in this side will be clockwise. Your value will be P AB square divide L square. The same value, same values. If this one is A, this one is B. I think I did. It will be P times A times B square. I'm sorry. Like this. P AP square divide L square. The same values. If this one is A, this one is B, okay, P A square B divide L square, P AB square divide L square. Same values, but I'm talking about the direction of this moment and this moment. Any question for this point? Any question for this point? Sometimes, probably, I will give you this example. We have fixed with the concentrated load here 9 kb and the concentrated load here 9 kb, and your distances is 5 feet, 5 feet, 5 feet. And I'm asking for what is the value of the fixed end moment here. What is the value of the fixed end moment here? Fixed end moment. Yeah, I understand that fixed end moment is one step of the moment distribution. Probably I can give you a separate question or separate problem asking only for what is the fixed end moment. So assume I'm giving you beam fixed, and the two concentrated load like this. So you will think, hey, this case, do you think this case is given? Is it this one? No. This one, the two concentrated load in the same direction, P and P. But this case, we have one coming down and one coming out. My question is, do you think this case, the whole case, is given here? No. No. So you will ask me during the exam, we didn't cover this case. No, we did. Do you know how? Okay, let me. This case or this scenario can be divided to by superposition, two cases added together. What do you think if I'm assuming this concentrated load alone? We have here 9. Is it 9? Yes. And this distances or these distances 10 feet and 5 feet. So we have distance A and B. Distance A equal 10, distance B equal 5. Can you figure out the fixed end moment? Yes, because this case looks like this one. Exactly. So we will have concentrated moment like this and like this. Your value will be P B A square divide L square. A P square B square divide L square. So I can get a value and I can get a value. I can tell you what is the value. So 9 this one will be 20. positive clockwise, and the other one will be negative. So the final conclusion from the first part, we have here positive 20, we have here negative 10. Does that make sense? Then I'm gonna assume we have this concentrated load alone, and your distances will be 5 and 10 feet. This distance A equal 5, this distance B equal 10. The concentrated load is coming from down to up. Your fixed end moment here will be in opposite direction, like this, but your values will be the same. B A square divide L square. B square divide L square. What is the value here and what is the value there? 9. Your value here will be 10 and your value here will be 20. And make sure this value, which is counter clockwise, is negative. This value, which is clockwise, is positive. Because both of them, this one and this one, are exist at the same time, your final moment will be, okay, go ahead and add positive 20 plus negative 10, your value or your final value will be positive, means clockwise, 10. Negative 10 plus positive 20, we will have positive, means clockwise 10. So this one will be clockwise and this one will be clockwise. Why clockwise? Because it's a positive. Why clockwise? Because it's a positive, due to the concentrated load here and the concentrated load here. Does that make sense? Guys, do you have any question regarding this one? Do you know how to solve it? Like this. You need to do superposition, assuming the first concentrated load alone, the second concentrated load alone, and then you need to add both of them together. So this value plus this value will give you this one. This value plus this value can give you this one. Anybody has any question regarding this point? Please give me a feedback. Do you have any question for this point? Looks good. One more example. One more example. I need to focus on this one. Okay. What will happen if we have concentrated fixed with the concentrated load here? $10 kb and concentrated load here 15 kb, and your distances 5 feet, 6 feet, 5 feet. You are going to say, what is the case right now? This one is 10, this one is 15. The only case with two concentrated load, this one, but this one, the two loads must equal. And your distances must equal the three distances, 1/3, 1/3, 1/3. But the case right now, we have two different concentrated load and your distances are not the same. How can I solve this issue? Okay. This issue can be solved by superposition. Assume we have this concentrated load alone 10 with distances A equal 11, B equal 5. So I can figure out the value of moment here and the value of moment here. I think my values will be 10 times 5 times. Your value here will be 23.6. The value here will be 10.7. And remember, this one is clockwise, it will be positive. This one is counterclockwise, will be negative. Plus, I'm gonna assume we have this concentrated load alone, which is 15, and distances A equal 5, B equal 11. That makes sense? This one is alone, 15. So we will have concentrated moment here and concentrated moment here as usual, clockwise and counterclockwise. Your values $35.4, $16.1. Clockwise will be positive, counterclockwise will be negative. Because the two concentrated load, this one and this one, are existing at the same time, your final fixed end moment. Go ahead and add the two concentrated moment. How much here? Positive 23.6. How much here? Positive 16.1. So your final value will be positive clockwise. 39.7. Your value here is negative 10.7. Negative 35.4. Your value will be negative counterclockwise 46.1. Here you go. Any question? Anybody has any question? Looks good. Okay. Sometimes we have example like this. Five kip per foot. 5 kip per foot. Wow. The only case we covered if the right angle triangle distributed load is covering the whole beam from this fixed side to this fixed side. But in this case, we have two opposite triangle. But this one is not covering the whole beam, and this one is not covering the whole beam. What should I do? Can you think about this? We have only one case. The triangle is covering the right angle triangle. In only one triangle covering the whole beam. Let me assume your distances are 5 and 5. We don't have this case right now. The only case we have triangle covering the whole length. one triangle covering the whole length. But right now we have two triangles, each one covering half length. What is the solution? Think, try to think. Any recommendation, any answer, anything? Okay, superposition, cancel, superposition. Okay, if I'm using superposition, okay, I agree with you. Cannot cancel each other because they are not at the same location. So if you are using superposition, so right now we have this triangle alone plus this triangle alone. Do you think this one, which is triangle at half length, looks like this triangle, which is on the full length? No, no. This shape is not identical to this one. We still have something wrong. And I cannot cancel this one by this one because they are not at the same location, one on the right side and one on the left side. So will not work. This one will not work. This one will not work. I cannot convert, I cannot change the shape of the loop. You have triangle loop. I cannot convert it to concentrated loop. If you have concentrated loop, I cannot convert it to distributed loop. You have to keep the shape. But I have another recommendation, which is very close for what Marcos said. Guys, what will happen if you... So the case right now, something looks like this. That's right. This value is 5, I think. This value also is 5, I believe. That's right. Okay. What will happen if you assume this 5 will be connected to this 0 and this 5 will be connected to this 0? So if you have this triangle 5 connected to 0 plus this triangle 5 connected to 0, believe me and trust me, if you add this triangle plus this triangle, the answer will be this shape. Let's try. 0 plus 5 is 5. The value here at midpoint will be 2.5 coming down. The value here at midpoint will be 2.5 coming up. If you add this value plus this value, you are getting 0. 0 plus 5 will be 5. So this final shape equal this shape plus this shape. That makes sense? So I think right now this right angle triangle looks exactly this one. So at this side will be WL squared divide 20. At this side will be WL squared divide 30. And this one will be opposite. So your moment looks like this and looks like this. At this side, WL squared divide 20. At this point, WL squared divide 30. And remember, this one is clockwise, will be positive. This one counterclockwise will be negative. This one counterclockwise will be negative. This one clockwise will be positive. Does that make sense? This shape or this case looks like, not exactly, but looks like this one. If we have fixed, and distributed load like this. 5, 8 kb per foot, and this one kb per foot. We don't have this shape, but I can convert this shape to two sheets. This one plus this one. I think the first one will be uniform distributed load. How much? 5 kb per foot. The second one, right angle triangle like this. How much? 3 kb per foot. Do you like to try? Let's try. Let's try. How much here? 0. How much there? 5. If you add this value plus this value, you can get 5. How much here? 3. How much here? 5. If you add this one plus this one, you can get 8. So this shape equal this one plus this one. Exactly the same like I did here. Any question? Any question? Looks good? This point looks good? If you have any question, let me know, please. Okay, let me solve the last example in this topic. We have a beam fixed at A, fixed at C, roller at B. We need to determine what is the moment at A, B, C, the final moment, using moment distribution method. Okay, let's start. Anybody remember what was the first step? By the way, we have two members, AB, and we have another member, BC. I will start with calculating the stiffness factor. K for member AB is the same like K for member BA. Member AB is the same like BA, the same member, equal 4 EI divide L. EI is not given, but it's a constant, so keep it. 4 EI divide L, which is 16. So your value will be EI divide 4. K for member BC is the same like K for member CB, the same member. 4 EI divide L. 4 EI and L equal 18. Your value will be 2 EI divide 9. Does that make sense? Second step. Do you remember? Distribution factor. Guys, when you are talking about distribution factor, please remember all the time the chicken. If you are living alone, you can eat the chicken alone. you don't need to distribute anything because you are alone. But if you have living with another person, another student, if you have your roommate, you need to make distribution. So if we have 2 or 3 or 4, we need to distribute. So we have point A, we have point B, we have point C. I think point A will not have distribution factor. Point C will not have distribution factor. Do you know why? Because at A, we have only one member. At C, we have only one member. But at B, we have 2 members. From this side, we have distribution factor for BA equal K BA divide summation K. The stiffness factor for BA, EI divide 4. Summation of all members at B for EI divide 4 plus 2 EI divide 9. I believe EI will be cancelled. So the value will be quarter divide quarter plus 2/9. 0.53. Distribution factor at B, but for the other side, which is BC, equal KBC divide summation K. So 2 EI divide 9 divide EI divide 4 plus 2 EI divide 9. Your value will be 0.47. Believe me, and you have to check yourself. The distribution factor or the distribution factors at B must equal 1. So that one for BA and that one for BC, if you add them together, you have to get 1. 0.47, 0.53, your value will be 1. Third step. Step number 3. Fixed end moment. First member, I'm gonna assume it fixed. Second member, I'm gonna assume it fixed. What do you have on the first member? Concentrated load. And your distances, 8 feet, 8 feet. So this distance equal 8, this distance equal 8. How much is the load? 6. Can you tell me the fixed end moment here? Yes, I can. How much? I think it will be 12. 6, 12. Because this one is clockwise, will be positive. This one is counterclockwise, will be negative. So M fixed AB equal negative 12. M fixed BA equal positive 12. The other member, distributed load 18.5. So your fixed end moment here will be like this and like this. WL squared divide 12. So 0.5 times 18 squared divide 12. This value will be 13.5. 13.5. This one is clockwise. This one is counterclockwise. So this one will be positive. This one will be negative. M fixed BC negative 13.5. M fixed CB equal positive 13.5. Any question so far? Guys, do you have any question so far? Okay. The fourth step, which is a game, I'm sorry, I'm gonna remove this one because I would like to solve it underneath the given problem. vertical line at each support. First step, what is the distribution factor? Something like this. At A, 0. At C, 0, because we don't have distribution at A or C. At B, we have 0.53, 0.47. Second step, fixed end moment. At this side AB, your fixed end moment negative 12. BA, positive 12. So we have negative 12, positive 12. For BC, we have negative 13.5. We have positive 13.5. Then I'm gonna do more 3 steps. Distribution moment, carry over moment, distribution moment, and then I can get the final. That makes sense? Distribution, anything related to distribution at A, we don't have distribution. We don't have distribution moment at A or C. We don't. The distribution will happen at B. How can I do this distribution? Okay, go ahead. Positive 12, we have this positive 12 plus negative 13.5. Your value will be negative 1.5. Go ahead and change the sign to be positive 1.5. Once you change the sign, okay, go ahead and multiply 1.5 times 0.53. We will get 0.8. 1.5 times 0.47, I'm gonna get 0.7. So I multiplied this value by this factor to get 0.8. I multiplied this value by this factor to get 0.7. After you did the distribution moment, go ahead and do this cross. Each value will go to the other side of the member by half value. So 0 to the other side will be half value 0. Point A to the other side of the member will be 0.4. 0.7 will go to the other side, 0.35. And 0, 0. One more time, distribution moment. Do you have distribution at A? No. Do you have distribution at C? No. Go ahead and do the distribution between 0 and 0. 0 plus 0 is 0. 0 times this factor or times this factor, I'm gonna get 0. You are done. Go ahead and add these numbers together. I'm gonna get negative 11.6. I'm gonna get here positive 12.8. Negative 12.8. I'm gonna get here 13.85. To check your final answer, make sure at B, this value must equal to this one, but in opposite sign. So the one is positive, the other one is negative, but the values are the same. Any question?